Okay, so this is a lesson on multiplying polynomials. What polynomials are, and poly means many, and the nomials, well, it just kind of means many terms. So it means it's a whole bunch of algebraic terms together. So these are algebraic expressions and they involve terms and numbers and constants and exponents. So these are formed by adding, subtracting terms. So for example, x plus 4. There we go. X plus 4. That's an x term, and 4 is just a number. It's a constant. That's a term. So is this 3 times x. That's one single term. Or you can even say 3x squared. Or 7. 7 is a term. It's a constant term. It's a number, right? Or you could even say 15x cubed y to the power of 17. Sure, that's one single term. It's got a constant out front, right? And it's got x cubed. And here's what they are. They are not equations. Oh, yeah. So an expression is an algebraic thing like this, but an equation would have an equals on the end. Yeah, so I'm not actually saying x plus 4 equals to something. I'm not actually solving. So what terms are? These are numbers or variables or combinations of them. Or combinations that may include exponents. Oh, yeah. So like terms means that they have the same variables and the same exponents. Same variables like x or y or whatever, and the same exponents. Okay, so hang on, there's a few different things. We can see a monomial. Monomial is like x. That's a single term. It means it's one term. So hang on, let's get rid of this. So it means one term. So it could just be x. Or it could be like 17x. Or it could be 158y cubed. Those are all single terms. That's one single term. A binomial means it's two terms. So for example, x plus 2, right? x, 2. These are two different terms. It's adding and subtracting terms. Or 17x minus y. Sure, that's two different terms. Notice you're adding and subtracting is what separates. There's one term, there's another one. Trinomial, 3 terms. And you know what? When we do 3 terms, we usually put them in order. Do the highest power first, like x squared plus 5x, and then minus 17. This is an x squared term. This is an x term. This is a constant. It's a number on the end. So we usually put them in order from the highest exponents going down. Okay, so the degree of the term is really just, it's the highest exponent. So in this case, this one has a degree 2. This one has a degree 1 because there's like an invisible x to the power 1. This would be considered to be degree 0 because there's no x's in it, right? There's no, it's the highest exponent of the variable. Or it's the sum if more than 1. What? So for example, this one is 158y cubed. What if it was 158y cubed x to the power of 4? And then I would say 3 and 4 is 7. This one has degree 7. The reason is, because think about it, if I was actually solving some kind of equation, there's 3 different y answers, there's 4 different x answers, there's 7 different answers. So this is degree 7. But if there's only one x, there it is, this is degree 2. So the degree of a polynomial is it's the highest degree of the terms. What do you mean? So like this one is a trinomial. Degree 2, degree 1, and degree 0. The entire polynomial is a degree 2 polynomial because that's the highest one, right? If this was part of a polynomial, it would be a degree 7 polynomial. Okay, so we can model multiplication. 13 times 11, you may have seen this before. It's 13 times 11 is really, 13 is 10 and 3, and 11 is 10 and 1. And if I think about area, right, 10 times 10 is 100, that's easy. 10 times 3 is 30. 10 times 1 is 10. 1 times 3 is 3. So if I was to add up all these, 13 times 11 should actually give me It's 100 plus 30 plus 10 plus 3. That's 143. And that's what 11 times 33 is. Okay, let's try it again. Let's go 42 times 46. So it's 40 and 2. Actually, you know what? I should make that one 40 and 6. And I'm going to make this one 40 and 2. 4 times 4 is 16 with 2 zeros. Yeah, 40 times 40. There we go. 40 times 6 is 240. 40 times 2 is 80. 6 times 2 is 12. Okay, so let's try this. So this should be 1600 plus 240 plus 80 plus 12. If I add them all up, 2, 12, 13, take up 1, 8, 9. Yeah, 46 times 42 would actually give me 1932. It's true. Okay, so that's doing it with numbers. We can also do this with algebra. Okay, so here's the distributive property. Now we're going to be doing some algebra. B plus C. So A times B plus C, which is in brackets. Normally, oh yeah, do what's in brackets first. But here's what the distributive property means. It means I'm going to go A times B. So this is going to turn into A times B plus A times C. That's really what this means. The distributive property means whatever you're multiplying out front goes into both of the terms in the inside. So I'm going to multiply into all the terms inside the brackets. Okay, so sometimes people call this FOIL, F-O-I-L. So it stands for firsts, outsides, insides, and lasts. So I'm going to do the first terms, then I'm going to do the outside terms, then the inside terms. It's really a shortcut for multiplying. So it multiplies 2 for multiplying 2 binomials. I'll show you that in a sec. Okay, so let's just simplify this. So here's really what this one is. This is 3 times x and 3 times 4. So 3 times x is 3x plus 3 times 4, 12. Done. That's all that is. So I'm just going to go 3 times x plus 4. This one is FOIL. So it's not just x times x. No, it means x times both of these. So x squared, x times x, and plus x times 8, 8x. Okay, so there's the first two. I did the first ones. I did the outsides, right? Now I'm going to do the insides. The -3 and the x. So minus 3 times x. And then the last one, last term. Minus 3 times 8 is minus 24. Now, if you do them in order, you're probably going to notice something. These are like terms. They're both x's. 8 x's take away 3 x's. Okay, so that's 5 x's. So I can write this out as x squared plus 5x minus 24. And you notice I've got them in order. X squareds, then x to the power of 1, and then the one with the no x's. Constant on the end. Most common mistake that people like to do here in math is x plus 5 squared is going to be x squared minus 5 squared. That's wrong, by the way. Let's not do that. We can't do that. That's not right. Something squared really means this. It means x minus 5 times x minus 5. Okay. This is a binomial times another binomial. Okay, so let's do this. It's going to be x times x, x squared. X times minus 5, so it's minus 5x. Now, the inside is minus 5 times x, minus 5x again, and then minus 5 times minus 5 is plus 25. And if I do it in order, you're going to notice these two should be able to combine. Here we go. X squared minus 10x plus 25. Yikes, this one's a little bit harder. 3x times 5y, so 15x squared. 3x times minus 4y, so minus 12x times y. Okay, now it's going to be minus 7y times 5x is minus 35 yx or xy. It doesn't matter. They're the same thing. So we're just going to call it xy because that way I know that these two are going to go together. Last one, minus 7y times minus 4y is plus 28y squared. Once again, if I do them in order, the middle two should combine. Here we go. 15x squared minus 47xy plus 28y y squared. This is a trinomial. This one is degree 2. This one's degree 2. And notice this is x to the 1. They're both. Yeah, this is degree 2 as well. But I put them in order. Okay. Let's step it up a little bit harder. 2 terms times 3 terms. So this is really going to be, it's not FOIL. Now this is like superFOIL. So 2x times all 3 of them. Whoa. So 2x comes here. I get 2x cubed. 2x comes here. Minus 8x squared. 2x times here is plus 4x. Now, my second step is I'm going to go the 5 times here, 5 times here. I'm going to do all 3 of them. Now, I'm not going to continue writing it on there. No. See, I'm going to be smart about this. Watch. Minus 5 times x squared is 5x squared. I'm going to put it underneath. I'm going to put it underneath the other x squared. 5 times minus 4x is minus 20x. And 5 times 2 is plus 10. So you see, when I add these up, they're all, oh yeah, they line up. So this becomes 2x cubed minus 3x squared minus 16x plus 10. Yikes, that's a big question. Same thing here. 2 times this times this. You know what? The first thing, I might just multiply this into here first. Now, this is not 2 times both of them. No. It's really 2 times this. So I'm just going to multiply this out right now. 4x squared plus 2x plus 6. Because it's really 2 times that. Now I'm going to multiply that whole thing by 3x minus 1. Yikes. Okay, so 4x is going to multiply into both of these. Sorry, 4x squared. So 4x squared times 3x, 12x cubed minus 4x squared. That one's done. Now the 2x is going to multiply it. 2x times here and 2x times that. And I'm not going to continue on here. No. 2x times 3x, positive 6x squared. Put it underneath x squared. 2x times minus 1, minus 2x. Continue on. 6 times here, this is going to give me 18x. Remember, I'm going to put it underneath the x. So plus 18x. 6 times minus 1, minus 6. Now I can just add all these together. So here's what I got. 12x cubed plus 2x squared plus 16x minus 6. Yikes. But once again, x cubed, x squared, x constant. So I've got them in order. Okay, this is going to be huge. This is going to be multiply these ones out and then subtract, multiply. So you know what? I'm going to do the multiplication first. So let's do this one over here. 12x squared plus 15x minus 2. So minus 8x and then minus 10. I know I can combine all those. Hang on. So before I start into this, let's just simplify this. 12x squared plus 7x minus 10. Now I'm going to do this one. So I'm going to subtract. I'm subtracting off the entire thing. Whoa. So this is, I should probably just do x times both of these. 2x squared plus 3x. Then minus 7 times both of these. Minus 14x minus 21. I should simplify that. So this becomes 2x squared minus 11x minus 21. But you remember, I'm subtracting this. So it's like saying minus 2x squared. And minus minus. Okay, so hang on. So let's simplify this. 12x squared minus 2x squared is 10x squared. 7x minus minus is plus. That's 18x. And the last one, negative 10 minus minus, that's plus. So it's going to be negative 10 plus 21. Negative 10 plus 21 is going to be positive 11. There's my answer. There we go.